design includes an inflatable building design, and like a balloon, it's lightweight and it's easy to transport. It will be inflated inside a magnet tube made with our 3D printer material made from lunar soil as a filament. And so it will protect from the solar radiation. And our model, as you can see, has different levels, where on the bottom level we have the treadmill, so important for SEL and also for physical needs. We also have the toilet, the bed, and the top level we have the agricultural lab. Further up, the second level, we have the engineering lab, and finally at the top level we have filtration.
As we began to research where we would place our lunar module, we researched both the north and south poles of the moon because the sun was more consistent in those two places. We found the Philolus crater, which is in the North Pole, where there is frozen water and resources available. The resources can be mined and the frozen water can be defrosted. The water can be used for drinking, breathing by breaking down the hydrogen and oxygen, and also for rocket fuel. And by building inside this crater, the habitat is protected from harsh temperatures, meteorites, solar storms, and radiation.
So our team chose to go with hydroponics as our food system because it meets many needs of the astronauts while they're on the lunar surface. First of all, it does give them the plants that they need for nutritional value, and if they plant a variety such as soy and lettuce, soy can give them protein, lettuce can give them water, and various other plants can be planted along these systems as well. But it also gives the plant the chance to get fresh oxygen to the astronauts while they're up there as well. The plants need the carbon dioxide that the astronauts are giving off, and the astronauts need the oxygen from the plants. So we have built a system where the plants are going to be throughout the walls of the building with their pipelines of water to feed the nutrient-rich water to the plants. And then we have a filter system that runs through the middle to keep the air flowing so that all of the living things get the air, oxygen and carbon dioxide they need. In addition to that, we have a composting system that will take any unused refuse and it can be turned back into nutrients to reuse within the system. We also hope to collect condensation on the walls that will be used and restored. The entire system is going to be recycling water the whole time, so we will not need to have additional water in our system.
So the Lunartic will contain a removable cover so that we can take advantage during the times of the year when sunlight is directly introduced to the Lunartic. This will be taken advantage by floors made from lead and glass mined from lunar materials and shaped into a convex lens so that it can be used efficiently throughout the Lunartic. The Lunartic will be powered by a fission surface power system, and this will generate whatever energy is needed. Each of these convex floors will contain a hatch so that our astronauts can travel between each floor using a fireman hook ladder.
So as you can see, the Lunartic is the world's first sustainable, self-sustaining lunar module that will allow for 5 members of the crew to live for 500 days. We can grow our food, eat it, store it quickly, and eat it again. We can survive for many, many, many days. We can dig into craters for ice and water. This has it all and will be protected by our wonderful new home, the Lunar Lava Tubes. We know you love it, so we look forward to seeing you in Houston.